Dear students, today we are going to learn a very interesting thing, that why we have been taking the angle of incidence to be equal to the angle of emergence in case the ray is suffering minimum deviation while it is allowed to pass through a prism having bilateral sides, means two sides are equal of a prism. In that case we have been taking like this, means angle of incidence was taken to be equal to angle of emergence, and we have all earlier explained in terms of taking analogy with the deviation in a glass slab, rectangular regular glass slab. But here today we are going to find it mathematically, how the statement which we have taken, that is I is equal to E for minimum deviation, that we are going to derive and prove it. Well, you see, we have already derived that the relation between angle of deviation and prism angle, angle of incidence and angle of emergence was to be equal to delta is equal to 1 I plus E minus A. Now this condition is derived only when we have the two sides of the prism taken to be equal. And once here you see A is a constant, it is not a variable. So what are the variable things? That whenever we vary the angle of incidence, correspondingly the angle of emergence will vary. So E and I both are variable, and on that depends the delta, the angle of deviation. What is angle of deviation? This is the original direction of the incident light DF, which is along DFI, and finally after it emerges from the prism, it is rotating, it is bending by some angle which is delta, that is angle of deviation. Now we know the mathematical condition for the optima, and optima condition is, for the minimum we have the derivation d delta by di must be equal to 0 for the case of minimum value of this variable delta, and it varies according to the angle of incidence, and therefore we have found the derivation, the differentiation of d delta by di. Now when you differentiate this term, this expression, here you differentiate I with respect to I, so that becomes 1, and then E with respect to I becomes dE by di, and minus, since A is a constant for a given glass prism, so the differentiation of this constant must be 0. So we get d delta m by di equal to 0. Here we are taking delta m expression, means that we are considering the angle of minimum deviation, and for the angle of minimum deviation this differentiation must be equal to 0. So we equate this term on the RHS to be equal to 0. So therefore we get 1 plus dE by di is equal to 0. That means dE by di is equal to minus 1. We shift the 1 on the right hand side, and then this implies that E is equal to minus I. And here the minus sign indicates that we are measuring the angle in reverse sense. If we are moving from light to normal, we are moving clockwise in this case, and we are moving anti-clockwise in this case while we are measuring the angle of emergence, and so therefore the negative sign is for to indicate that thing. So that means the magnitude of angle of incidence is equal to angle of emergence when the ray is suffering angle of minimum deviation, is suffering minimum deviation due to the refractions taking twice place inside the glass prism. So that's all for this topic. Please enjoy learning.